So hi everybody. So as mentioned, my talk is about modern post-exploitation and what to do once you gained access to any account or access. Now you're hearing me better? Great. So my talk is about modern post-exploitation and what to do once you gain any level of access. And in homage to the classic anime Ghost in the Shell, I named it Ghost in the Cloud. So who am I? Why am I talking to you? I've been researching and hacking for many years. I've been the CTO and co-founder of several companies in the cybersecurity domain. And before anyone is running here, I am happily married. So to move on, what am I going to talk about today? I'm going to talk a little bit about the introduction of what is IAM. And IAM is not an AWS mechanism. IAM is identity and access management. It's the infrastructure that manages the access in any application that you have. I'm going to talk about how these architectures work in organizations and in applications and what's vulnerable there. I'm going to talk about how access automation works, how access is being provisioned and why this is vulnerable. And then I'm going to show you a bonus of how to troll open SCIM servers to take over organizations that are really not careful with their access. Following that, I'll show an analysis and taxonomy of these type of attacks, which is a growing attack surface. We've seen the SolarWinds attackers, for example, the group that is sometimes called Nobilium, use it, and I'm going to show how to analyze new applications, how to perform a taxonomy of that, and how security tools that are emerging in these domains work, and how to evade them. And lastly, I will show you a demo of how all this ties up based on a real organization, which I reproduced their environment, and how to get from an employee's Gmail access to full control and exfiltrating all the data about the customers of that organization. So without further ado, let's start. How do enterprise IAM architectures look? First and foremost, they look terrible. They are really messed up. And as part of this, what you actually see is that an organization is similar to a software program. Data or information is feeding into the organization. Different services, which in the case of an organization are people, are processing this data based on certain permissions that they have. The data flows are defined by the authorizations and by the IAM. And I try to build this analogy a bit further. So let's take this analogy a step further. What we see now is sort of an analogy to network security or software security. It is limited, and IAM security. What we see is, for example, a service or a class is similar to any actor that you have in your systems. A firewall is similar to the authorization logic or the IAM controller. An asset or an object that you protect through IAM permissions is generally a server, a database, an execution control in the traditional network world. And the most interesting thing is self-modifying code or a buffer overflow is equal to the ability to change permissions. But in difference from modern software applications, for example, where you have DEP, read-only memory, JOP or ROP protections, and so on, there are no protections in the IAM domain, mostly. Generally, 99.9% of the organizations that I have seen, their IAM system acts as self-modifying code. That means that you can literally see what's happening and modify the program as it works, modify the behavior and the rules of access in the organization. So let's talk a little bit about how these architectures look and start from the past. Once upon a time, used to be that there were users connecting to an application. This is not working well. Okay, users were connecting to applications. The applications were connecting to an LDAP directory like Active Directory, and that directory allowed you to define the access and the authorization. Then came hardware capital, human capital management or human resource information systems, and those started to provide attributes that control the access to those to the LDAP directory, and the LDAP directory control the access based on these attributes. But there's one thing that you need to pay attention to. An HR or an information system or an HCM is an application in and of itself. So it's controlling the access to the Active Directory, but at the same time it's controlled by the Active Directory, creating a cycle. And these cycles are very dangerous because those are the places where potential escalation passes and role chaining attacks begin. So to move a little bit further, going more modern, we started having SSOs and directories, and these were connected through federation to different applications. Now, federation generally comes in two flavors. One is where the application itself saves the users, knows who is the person, and the federation is only serves to identify the user that is saved within the application. The other, for example, the way AWS is commonly implementing this, is based on granting access to the SAML assertion arriving from the federation. So the user itself is unknown to the application. The application, whatever assertion it got from the SSO provider, is trusting of it. And naturally, SAML is not the only federation method. Actually, there are a lot of federation methods still in use even today, where SAML is clearly the winner. Last thing to mention, you don't only source from HR applications. Sourcing attributes that control access is done for many other different applications. But before we even talk about this further, I just want to remind to everybody, SSO support is also very costly. It's not free. And this site is fairly cute. This is SSO.tax. It's an open source GitHub project, and I encourage everybody here to contribute to it. I have no disclaimer, I have no affiliation with that project. I just like what they did. And what's really cool here is that they went and they priced what does it cost to get the full SSO support from the vendor. For example, in GitHub, to get full SSO support, you go from $4 per user to $21 per user. Which makes it something that a lot of organizations won't spend the money on because it's not really worth it. Going back to the talk and assuming you really still have SSO for everything and federation, let's add a directory that is separate from the SSO. In this case, the directory is, for example, an LDAP directory like Active Directory. It syncs, unless you're doing a really crappy job, with your SSO. That might also have a directory, and controlling the access, and then the sourcing can happen both to the directory and to the SSO application itself. And this creates a lot of mess and potential conflicts of attributes and problems in sync, which tends to cause a variety of problems. As we move on, provisioning became more prevalent, and it's becoming more and more prevalent in this world all the time. And provisioning is protocols like SCIM. I don't know how familiar are you with the SCIM protocol, but the SCIM protocol is a protocol that is used to move certain types of data into the application. In particular, it pushes groups, users, and attributes, and it's a bidirectional protocol, so it also supports pooling in certain cases. Not all applications support all the features of SCIM, even if they support SCIM. What you see on the screen right now are the statistics that I made based on the Okta integration network. And yes, I scraped their site. If this is a violation of the terms of service, I apologize. But the point here is to show you that applications support different things and they are not in sync. Not all applications that support updates a user account support also deactivating the user account, and vice versa. And not all applications support group pushing or group linking, which are, to my personal opinion, unclear why they are separate. Because group pushing is the act of adding a group from the SSO server into the application and managing the users. Group linking literally links a certain group from the SSO to the group in the application and updates the users based on the SSO. Now, this is first and foremost a source for confusion, but in addition to that, it doesn't necessarily cover all sorts of time of check, time of use scenarios where a user was added on one end and not on the other, or was removed on one end and not on the other. So this is about provisioning, and provisioning is not all that's happening, right? And enterprise applications are linked from one to the other. For example, here what we see is Jenkins is connected to GitHub, where it reads the data from about repositories, and then it pushes this data into AWS. but in most organizations, it's also running inside the AWS infrastructure that it is updating. So it both controls it and is able to control it, and it also creates an imbalance of permissions. A user that has access to GitHub might use Jenkins to gain access to AWS, or will use it in many cases. So let's add a little bit more complexity, because organizations have to have complexity in their architecture. Let's add external applications. In addition to the internal applications that you have within your organization that you bought, there are external applications that are connected to those. For example, Box is commonly connected to Salesforce, or Calendly is commonly connected to Office 365 and Google Calendar. And through these connections, what happens is that additional permissions that you didn't necessarily intend to are created, and potentially also data leaks. But actually, it gets worse, because the organizations are provisioning for multiple applications. And this is where it becomes really, really crazy. You don't have to provision only from the HR application. It's actually a fairly common practice to provision from Salesforce. And you don't have to provision to the same target. You can provision to your directory, and you can provision to your SSO. And as you provision these attributes, and they control the provisioning of access and the management of access in these applications, it becomes the chaos that you see on screen, right? And the chaos doesn't really end here, because a lot of organizations actually work with multiple SSO vendors at the same time, and multiple LDAP directories at the same time, or any type of directory, not necessarily LDAP. Now, when I say this, you're probably thinking, is bullshitting us, right? Nobody would work with such a complex architecture. So I drew the architecture of a real customer that we had 2 years ago. And this is also, the drawing is taking some still simplifying some of the stuff. So for example, what you see here, there are 180 apps that I completely ignored. For example, Slack, that is literally connected to everything. But just to take a look at what we see here, they had 3 different SSO providers connected to 3 different environments. All of those had a certain level of directory. The directory sync between Google, which was their previous SSO provider, and Okta, which was their new SSO provider, was broken, meaning accounts that were shut down in Okta, the main SSO provider and directory provider, were not shut down in Google. And at the same time, AWS maintained 2 federation options. At the same time, you could log in federated through the Google legacy method and through the new federation through Okta, which created a lot of mess in their environment. And in addition, you had multiple applications like GitHub, which bring your own identity, which is a complete problem for organizations, because developers come with accounts that can't be correlated to a specific person in the organization, and it creates a whole chaos of management in that sense. And lastly, they had, of course, external applications connected. They were sourcing at the same time from Salesforce and HeyBob to Okta, but that didn't necessarily translate to access in Google, and vice versa. Google Access didn't necessarily have updated attributes from these applications, meaning people that should have lost access didn't lose it. So I'll take a pause here and show you as a bonus item, just sharing about how to troll open SCIM servers. So as I mentioned, SCIM is a protocol that is meant to assist provisioning of identities, groups, and attributes from central directories to your applications. But as you do this, and I just scrolled the internet fairly randomly, or used Shodan, or used some Google Dorking to basically find potential SCIM servers that would have either default authentication or no authentication at all. And in July 20, when I was supposed to speak a little bit before that in Hack in the Box, a previous presentation, there were 233 of those. And after the presentation didn't happen because of COVID, I decided to basically do what you see here in the Jupyter Notebook, which is to basically post a request to all of these servers and let them know by creating a user that they have an open SCIM server. Excuse me. And as I did this, what actually happened, which is fairly nice, is that in November 21, when I tested these same queries again, only 26 results returned to my previous search. As these 26 are still vulnerable, I'm not giving you the search, but you're smart people. I'm sure that if you want to, you will be able to find the same results or even better. So let's talk a last topic about automating access before we get to actually how to analyze applications and how to hack them. So automation is a good thing in general. It reduces the amount of human mistakes, it saves effort, but it also does an important thing in the area of access management, which is providing us with a really fun attack surface. And it starts from automating attribute-based access control. So attribute-based access, and there are different types of attribute-based access control. There are dynamic groups, which is a concept from Microsoft, but there are equivalents in many other places, which is basically means that the group membership is set based on attributes of the identity. And that means that controlling the attributes of that identity allows you to control all the access that this identity has. For example, if a certain access is assigned to someone that has the title CEO, it's highly likely, and I've seen it in about 95% of the organizations that I worked with, that you can literally have some HR employee grant anyone the title CEO for him to have almost all the access that the CEO has. It's no work, it's not hard. In some cases, there is also self-service portals allowing the users to grant themselves the titles. And once they grant it, they are basically granting themselves the access that comes with the title. And it is almost certain, I know of no company except mine, and this is not an advertisement, that literally monitors this. So in 99.9% of the cases, nobody is monitoring this access. And in addition to that, there are other things that you can consider, like how do people add manually a certain person that doesn't match the rule because they have an exception into that group? And the interesting thing is, usually they do it using rules that are not really smart. Because, for example, they might rely on the phone number, or they might rely on the fax number. These are real examples that I saw in real organizations. Because it's a pain to find the object ID in Active Directory, for example, or in Okta there is no object ID at all. And then there are also other challenges, like cascading rules. For example, your membership in certain type of group could depend on the membership in another type of group. So before you know that the first group actually is provisioned, you won't know that the person can also access the second group based on that. And this chain becomes invisible to any defender and only visible to you as attackers. And lastly, as I mentioned before, attribute linking and sourcing is extremely dangerous because it provides people with a specific permission. For example, the person that can assign people a territory in Salesforce, because this territory is an attribute, and because this attribute will be provisioned to Okta, and from Okta control access to other applications, it generates a huge vulnerability in the attack surface that is based on personnel that are not necessarily senior in the organization and that are very hard to identify. So, other than this, we can also have fun with groups. I mentioned before, group push and group linking behave differently. And this is really interesting. Group linking doesn't have to match the names, meaning I can choose a certain group that is not benign at all, my personal group, and connect it to a very malicious group, a very important group, like my top managers and admins in GitHub. And this creates, again, a situation where you can't see the access that was linked. There are also challenges with time of check and time of use that I already mentioned. There are challenges with prioritization of the access in groups and roles. Who wins when there are several permissions at the same time. And group syncs, which tends to fail in a lot of situations. There are known issues, for example, syncing Google to Okta, Okta to AD, and so on. And lastly, very common are public groups or publicly administered. This means that public group means that anyone can join this group voluntarily. You can just go in Active Directory or in Office 365 or in Okta and join the group. And this surprisingly is a default setting in a lot of cases in Office 365 when you create groups, meaning that a lot of groups in Office 365 unintentionally are actually granting access not only to the people in the group, but to anyone that will decide to join that group. At the same time, you can also have publicly administered groups. This is common in Google, meaning anyone in the group can grant other people access to the group, not necessarily the person that is supposed to grant it. And I can go through other similar issues. The most fun one in this slide is the just-in-time user creation allowed through social logins in some applications. Okta, for example, supports this. But it comes down to one very simple question. Who guards the guardians? Which is the motto that you see in Latin here. Nobody is guarding the guardians. IAM layer, the access and authorization layer, is the guardians of access to your critical assets in organizations. But nobody is monitoring it, nobody is guarding it. So that concludes the first part. Let's talk a little bit about taxonomy and analysis. And it begins with trying to, has any one of you tried to apply the MITRE attack matrix to something in SaaS or IaaS? Because it feels a little bit like this animal. I have no idea how to name it. It's a shark, it's a dog, I don't know what is it, but that's the way it feels. So generally, what I do want you to think, whenever you face a new application that you need to analyze and understand how to attack or how to defend, the first question that you need to ask is, it's a complex landscape, just like this picture. How to understand the landscape and to know what to do in it is very challenging, but you need to build a graph of how the permissions work. There are two choices here. You can build a graph that is dedicated to a specific target, which is easier, and you can build a generic graph that will cover the way the permissions in the application work. I'm going to try and explain a little bit the methodology that I use to build this graph. So it begins with finding the asset of interest. Once you find it, an asset for me is anything that can be controlled. You need to find the actors or identities, anyone that can do actions within that application, and find the authentication methods that are supported for each, analyze the federation methods if those exist, and map the roles and the groups that exist. Eventually, get to the point that you understand the passes through the application. It's very important to account to one thing. There is a duality, which I have talked about before, the duality that creates the cycles. The actors and the assets could be the same. Having permission to change an attribute is a permission to control an identity in a sense. Having permission to change the password of the identity is the most simple and easy way to think about the permission to change an attribute, right? Or to control an identity, not to change an attribute. And lastly, there are a lot of automations before I leave this slide. And it's very important to try and understand where are the automations that the IT department in that organization did in order to automate the granting of access. So let's take this through an example, so I don't just wave my hands in the air like I do in this talk, and show you that it really is possible. And I'm taking an example of analyzing GitHub, and I'm doing this for a specific target repository that I want to target. Now, it's important to note I'm doing this as part of a context for the demo that I will show later of how to take over from a Gmail account to compromise the customer data of an application. So it begins with the very basic question. I know of a target repo. What grants me access to this target repo except direct access? The answer to that is an organization. A GitHub organization grants access to all the repos inside that organization. The next question is, who has access to those? So I know the organization owners can do anything to the organization, and I know that the repo admins can disable branch protections or force push to different branches, which is interesting because I want to push code eventually. This is my core element in GitHub. And lastly, I can find out which teams are assigned, which users are assigned to this access, and so on. once I do this, I can look at the federation, automation like team sync, personal tokens, and other authentication methods like OAuth apps that can grant me access to these identities and actors and the access that they have. So to take this a step further, let's try to map this into a taxonomy. The way I build a taxonomy is thinking about the graph that I just showed you and thinking about the nodes, the edges, and the automation edges that exist in this graph. And for each one, I'm thinking about the CRUD elements that can be targeted. So, for example, I won't go through this table. This is not the goal. I'll publish the slides, and anyone that is interested can happily use them. And to take this further, I'm planning to make this an open source taxonomy that anyone can use. But, for example, an identity node, the ability to create it means the ability to add a user, a service account, or install an application, because an application, like an OAuth application, is an actor in your system. It sometimes is represented as a service account and sometimes as a different animal in some applications or platforms. The ability, for example, to create any token is what's called the golden ticket type of attacks, right? It's the ability to generate tokens arbitrarily. So I can take this, talk about nodes, I can talk about edges and talk about the high-level types. There is a membership edge granting access to a group or a role. There are permission edges granting certain privilege to a certain asset or set of assets, and there are inheritance asset edges on which access flows from certain assets to other assets. And lastly, there are the automation edges, which are very interesting because they automate the granting of access. For example, membership rules in groups, for example, user and group provisioning, and data links. And then there's one unique exception, which is the ability to control an identity. Any asset or object that grants you the ability to control identities, like the master key that grants you the ability to mint tokens, controls identity type of edge, and it represents a cycle in the graph. And these cycles are what generates, again, the escalation passes and the weaknesses in these environments. So to take this and try to map this to the weird MITRE attack and the more traditional approaches, when we look at discovery and mapping, I'm trying to take any attack here and give it a sign in the taxonomy that is based on the first letter is the node, edge, or automation. Second letter is the type. For example, a membership edge would be EM. Node, node of identity would be NI, and so on. And you can see here, for example, enumeration APIs grants us access to any type of edge node or automation, any type of access, and eventually read level access in the CRUD, which is the third letter, and it's very, very wide. And it's worth noting, because as you have these items, you can look for the specific type of the next object that you need as you attack a certain organization. If you know the enumeration of where you are, you can understand where you're going and look for the next gadget or piece. Because in a sense, all of these are gadgets similar to rope gadgets that you need to build up your exploit code in the organization. And when we start thinking about this, we can also think about persistence. And here, for example, I drew the illustration of how a golden ticket type of attack actually works. And because the master key can generate access tokens, it creates the cycle that I talked about. And we can talk about other techniques here. This is not the core that I'm going to talk about in this talk. Let's talk a little bit also about privilege escalation. Privilege escalation is very complex topic in IAM security, because if you look at it, finding methods to do privilege escalation grants you the ability to move laterally or escalate. At the same time, using these methods intentionally is the best way to hide your access. For example, building role chains or building cascading rules of access intentionally grants you the ability to have invisible access if they are based on any attribute or anything that you control. which brings us to the analogy of what I actually do and what I think I do are not as complex, right? And what is illustrated over here is an escalation path that is based on access to a service account and several role chains granting us access to a certain target asset. Finally, we can also talk about how this hiding access or escalate or lateral movement can work. And you can make a group public, for example. You can control an attribute that affects the automation, role chaining, which you saw in the previous slide, but also interesting, and we've seen it a lot, inactive users. Inactive users is really cool because almost all organizations have them, almost never being cleaned up. And then the really fun part with inactive users is when you start looking at, and we saw this literally, for example, after the Colonial Pipeline attack, in one of our customers, an inactive user revived. So this is, and the customer is an oil and gas company, so not really surprising this is happening there. This was an employee that moved from that company to Colonial Pipelines. And similarly, we can see golden tickets, we can see shadow admins. Shadow admins is pretty cool. It's building up an admin role for multiple pieces that are not privileged individually, not highly privileged, so it won't be monitored. But piecing those pieces of the puzzle together can grant you the same level of access without the work. And empty row groups are another nice way to do this. When you have empty groups, you can grant them access. Nobody will care about this access because there are no members in this group. But if you are, for example, the owner of this group but not a member, which is literally possible in Active Directory by design, you can not be considered as having the access when somebody is scanning it, but you can add yourself or anyone else at any given moment. So there are a lot of fun elements like this, and every app is different. This is why it is important to understand how to analyze any new application that you're facing. Another cool thing that a lot of people don't know is our features like e-discovery. E-discovery is a feature from Office 365 compliance infrastructure, and it allows you to search all mailboxes without having any direct access to the mailboxes. As long as you compromise the e-discovery permission, you can literally access anything at the same time. So finally, we can talk about exfiltration. There are a lot of methods for exfiltration. We can talk about cross-organization permissions, which is common in, for example, AWS and Azure, where you can grant access to another organization that is a different tenant in that same service provider to certain assets in your organization. Now, in theory, this is a valid use case for companies, but at the same time, it creates a very invalid potential use case or access, where as an attacker, I can create a policy that grants access to my fake organization, and it's very hard to know which organization is granted the access and monitor it. Another tip, applications. Applications are not monitored even if users are monitored in most organizations. So if you install an OAS app inside any platform like Office 365, Salesforce, whatever, it's 99% certain this OAS app is not monitored. The activities, the actions that he is taking on behalf of the user that installed it are not monitored and not validated, because it's assumed that it's very hard to understand the actions of that app. As those actions are not monitored, it's very easy to use applications like OAS applications to do this. And nobody's checking the names when you create an OAS application. So you can just name your OAS application as something really benign. I can name any OAS application as Dropbox, new app, and have it installed in any target that I attack, and it will work because nobody is actually checking the name and nobody can validate the name. There is no even directory of valid app names and IDs that you can, as a responsible administrator, validate based on. Lastly, data links are very interesting because data links allow you to connect several assets and move data automatically between several assets, preserving the access that was predefined. So, last thing that I'm going to talk before I move and start talking about start talking about showing you the actual demo. So a little bit about the emerging classes of security tools that try to manage IAM security. So cloud infrastructure entitlement management are applications like CloudNox and Hermetic and Automize, my company, that generally connect to AWS, Azure, and GCP. They analyze the entitlements or the permissions there, and based on that, they try to make decisions. SaaS security posture management are platforms that try to do the same for SaaS applications, but generally SaaS security posture management is less about entitlements. It mainly focuses on misconfigurations. Some of the vendors, as part of the misconfigurations, also try to identify misconfigurations that are related to privileged permissions, SSO settings, and things like that. And SaaS management platforms try to do the same for and to automate certain access. They are very similar to SSPMs in most cases, but they tend to be more focused on getting the automation right rather than monitoring the access. And how do those actually work? And this is the question that you really should be asking yourself if you're an attacker. They subscribe to events, they connect to APIs. That means that they are limited by the type of events that they can subscribe to. They are limited by the APIs that they can rate limit to. They are limited in the resolution sometimes. Sometimes they intentionally don't have deep resolution into the application. They might only capture the assignment to the role and not modifications to the actual access, that the default access that this role is granted. And lastly, many of them don't have threads across all the services there. So lastly, I'm going to give you a short demo. The demo, one does not expect the live demo to work, so I'm not going to show a live demo, and I apologize. If there is time, I will show you a little bit of live, one part of the demo live, and how you actually exfiltrate the data really, really easily. But please bear with me. Everything in this demo is based on a real customer environment that I have reproduced because I can't disclose the environment of my customer. But it's a true enterprise that actually has millions of customers, B2C. And what we are going to try to do in this demo is actually compromise the asset that they define as the most important, their client database, the emails and the passwords and all the information about all the customers. And it begins from the basic assumption that we've gained some initial access to a Gmail account. And this Gmail account is associated with a certain developer in that organization and his account. So, to start with, this is what we know. Ray Reckerman is the person that we gained access to. And Ray Reckerman has access to our target repository that through a continuous deployment process is deployed to GCP and manages the access to the customer data. It's a service that generates statistics and works on it. And to this repository, as I mentioned before, there are two ways to get in GitHub. One is to be a repo admin and either disable or force push, because this organization is very strict. Code reviews are happening by two people. Two additional people are looking at every piece of code. So you have to work around this if you want to sneak code. And I'm not, I know that there are other smart ways to do this, but let's assume that that's not the way we want to go. So the first thing we're going to do once we gain this access is to get a new personal access token. This is very easy to give GitHub full credit. They're emailing you on this, but if you have Gmail access, you can just delete the email forever, hopefully. And once you did that, now you have a fake token that you control that can act as Ray Reckerman. Now you no longer need to sit on the machine. You no longer need to be visible in any way, because you can talk directly to the GitHub API, never passing through any place that the organization can deploy any security software or applications like an APP. Now that we have this, and I'm intentionally using coloring, and this is very useful if you work in this type of manner. Coloring is really helpful to understand where you are and where you're going. So let's use this API key that we have to enumerate the access. And in this particular case, I'm enumerating the access through the GitHub API. And as you can see, I found a group that has admin access to this repo. By the way, I also left the API key over here. You're welcome to try using it. It's for a non-real organization and it's deleted, but for those of you bored enough, you're welcome to try. And let's agree that if we can push code to GitHub, we can run code on the dev's computer, because I can push the code for those that it's unclear to the dev's own private branch, and then they will run it all the time. So now what we know is that there is a group called demo repo admins that we found in the previous slide. Maybe I'll just make sure that you all saw it. This is the name of the group, right? So demo repo admins. So now that we know that we can get access if we can get assigned to this group. But how do we get assigned to the group? So let's look at Active Directory. In Active Directory, we can find a group with the same name. And here I also opened already the rules in Active Directory. But let's assume we didn't know the rules, but we do know that in Active, and this is the situation that you will normally be in, we do know that all the engineering managers are in this group, and one person who is not an engineering manager. It's the engineering director's personal assistant. And now what we need to ask ourselves is the question, how did they grant the exception? Because this is a dynamic group that is meant for the engineering managers, and this PA doesn't have the title engineering manager, how did she get added to this group? And the answer is, the organizations use different attributes to create an exception. So the attribute that you should actually be using in the example of Active Directory is Object ID. But Object ID is actually very hard to extract, and people feel that it's complicated and it's unclear why it is used. So what they actually tend to use are attributes that they can set and are not necessarily in use or might be in use but not really, like the fax phone number, real. I've seen this practice in at least 5 organizations, using the fax phone number to assign people to dynamic groups. Similarly, you can look at the mobile number and the telephone number, which I've also seen in other organizations being used. So under the assumption that this person is actually using this, and we're guessing that it's either the office phone or the mobile phone or the fax number that was used there, now we have this understanding of the organization. We know now that there is a dynamic group that we are guessing is team synced to the team in GitHub that has the same name. And we know that Samantha Fox, who is the PA, has access to this group probably through the office phone. I'm cheating here because I already know the answer, so I wrote the office phone, but you're going to assume it's one of the attributes that you want to control. Luckily, this self-service, the picture you see in the background is Manage Engine AD Self-Serve, which is a very popular application for Active Directory self-service. There are also many other options. As you can see in the example, which is taken from their site, because I didn't have access to this application to reproduce it, in some cases, users can even change their own title. So I could go ahead and change my title to Engineering Manager and just get the access. But let's assume they can change the title. What they certainly can change are attributes like their office phone, mobile phone, and so on. Or request it even from IT, because it's not really scary. To simulate this, I did the same in Active Directory, which is what you see on the right-hand side of the slide. And I basically set my phone, the phone of this fake account intentionally to that. Now I know that the fake account has this phone number, and it takes about 3 minutes or 4 minutes to see the results in Active Directory and see that he is now a member of this group, the dynamic group that we call Demo Repo Admins. But what he is not yet is not a member of this group in GitHub. And waiting even 10 or 15 minutes, you still don't see a change, because sync and automation doesn't work that fast. But 51 minutes later, or to be accurate 47, because this screenshot was taken 4 minutes after the access was granted, this sync is happening. And once the sync has happened, what actually happens is that this person, the account that we control, now gained access as a repo admin to our target repo, which looks like this. One thing to say in GitHub's credits, they send a lot of emails about these access changes, and it takes a lot of work to actually prevent the access. There are some configuration settings, but not that much. So now that we have the team sync, we basically managed to compromise the entire chain and we can push our code. But we still want this code to stay there for a long time, right? And we want to exfiltrate the data in a way that will be as invisible as possible. So, and obviously, similar to that, between the point that we push data to the target repository and the point that it arrived in GCP, we need to wait for a CD process or a release point in time that the code will actually move. Now, when I looked at this target repo, and this is again based on the real customer, but the code that you see here is not the original code, just similar code that I found on the internet. Basically, it's a very common practice to push from GCP to an application, to Google Sheets, to a worksheet in Google Sheets, information about what we actually want to export from GCP to use in the organization. And in this particular real-world example that I'm basing it on, they push the stats about the customers that they had. How many are male, how many are female, how many are young, how many are old, age groups, all this type of stuff. And as they pushed it, this is the picture that we have. Now we can push the hidden customer data as, for example, a hidden worksheet to the same worksheet that is anyways being created and updated in Google Sheets for the stats for the management. Now, this is very easy to do, but this is not an easy way to exfiltrate the data all the way to my personal area without leaving any trace. So I can take a step further, and this is where data links like are really free exfiltration tools built into the platforms. And in this particular case, the data link that I generated is a data link using import range function. Basically what it means is that a user that has access to a certain asset can pull information from one worksheet into another. And that means that now I created three worksheets. One is the user stats for the management that is written from GCP. The second is called results QA, which is used to verify some results and is only accessible to the user that we have compromised, who is responsible to QA his work, right? And the last one is called bills to pay. It's a private worksheet in his own drive. And the links go from one to another to another. So even if you find the first link, it doesn't look malicious. And the second link is unlikely to be found. And this basically looks like this. Now we can use two import ranges to go from one to another. And lastly, the bills to pay is something very valid to share externally with your Gmail, with anything else. To complicate things further and how we can utilize the IAM mechanisms for our advantage, what we can do is also limit the user stats for management to have only view access. What that means is now the management can't view, based on the permissions that Google uses, they can't view hidden worksheets. So they can't even know that they pushed more data into the same worksheet and hide it in there. So this is fun. And let's look, do we see the access that was granted to import range? Yes, but it's granted like this, as unknown can view. Would you notice it? Would you know what it means? How would you actually investigate it if you looked at the user activity? You probably wouldn't, right? So this is basically where we are and how we can exfiltrate the data. I'll go back for a moment to this slide. So this is the entire process that we did, right? We took over a fake token, an account. We used the access to Gmail to generate a fake token in GitHub. We used that also to analyze the GitHub API, found the group that we want to compromise, found it in Active Directory, found the exception and wrote the exception to gain access to that group, utilized the team sync mechanism to gain access, using that push data, malicious data into that GCP account, and through that and a series of import ranges, managed to push the data all the way to our target very, very covertly and automatically, without almost any actions that we needed to take that would allow anyone to know that we are interfering in the normal behavior of that organization. So let me check the time. Okay, I'm going to give up the live demo. If anyone is interested, you can catch me afterwards and I'll show you a couple of pieces of the live demo. To finish and leave some time for questions, some takeaways. The modern enterprise attack surface is mainly built around the identity perimeter or the IAM controls. And IAM architectures are complex and they rely heavily on automation of granting access. The IAM mechanisms in general, especially around automation, can be reused. Just like you can reuse ROP gadgets when you're exploiting a binary application, you can reuse pieces of IAM applications when you're attacking an organization and trying to move between all the applications the organization has and the infrastructure that it uses. When you're analyzing or classifying an app, think where the pieces fit in the analysis graph and what are their CRUDs, whether these grant wide access or specific access. And security tools in this domain are, first of all, emerging. They are rare in most applications. And second, even when they exist, they face certain limitations because of the vendors themselves limiting the access. Thank you. And if you have any questions, I'm happy to answer them in the next 2 minutes.
Thank you, Gal. I am looking online. I see no incoming questions at this point online, so I'm going to take you to the room. Any questions from the room? Okay. Thank you, Gal.
I think there is one.
There's one. Okay. One moment. I'll bring you the microphone. Please speak up loud so the speaker can also hear.
Okay. Can you hear me? Okay. So my question is there an absolute way? And is there a full solution that properly shows you everything that's going on with all your IAM solutions?
So your question is whether there is a full solution that
Yes.
can look at all the IAM architecture.
Yes.
So
And create specific alerts where you can find out things.
I'm feeling uncomfortable because I'm not here to advertise my company.
Yeah.
But my company is one of the solutions in this area. Other than that, there are a few companies that are more specific. For example, the SCIM that only looks at public cloud, or the SSPM that only looks at SaaS applications. But the only company that I know that is really across the board is my company. So I apologize. Didn't mean to advertise, but I'm happy to do it.
Does that also mean that if the design of your identity management system is flawed, then you'll always have problems? But if it's perfected in a way, like if before you design that infrastructure, the groups and everything, and assign them accordingly, will you be protected? Will you not need this anymore?
So I'm not sure I entirely heard everything, but you asked if the design is flawed in the way the infrastructure actually works because you can't actually secure it well?
Yes. So what I mean to say is if you design it properly enough, can you be like fully protected? Or will there always be a way of getting around?
There are two elements to this, in my opinion. One, and again, this goes to what we've seen, and Nobilium is the best example for that as an attacker. But attackers are utilizing this now because it's the easy, less costly, and very, very covert way to do things. Now, the one thing that I can recommend on design is make your IAM architecture immutable. In code, you wouldn't allow you wouldn't allow self-modifying code, right? But in IAM, self-modifying permission system is the de facto standard. Why is it like that? I have no idea. But there are two things. One, make it immutable. Two, even if it's immutable, you can't validate that it's immutable. This is why, don't forget, this is why I put this statement here. Don't forget to guard the guardians. IAM is your guardian of access to anything in your organization, but you need to guard it, meaning you need something to monitor that access, effective access at any given moment, and tell you if a change doesn't match the architecture that you designed. I hope that answered the question. Thank you. Okay, thank you all. Appreciate the time and hope you enjoyed it.
Thank you as well, Gal. It was a great talk.